All right, 3.3 with properties of logs. Basically, what we're going to do is we're going to do three things. We're going to expand a logarithm, we're going to condense it, and then we'll do change of base. With any of this, whenever we have a product rule, whenever we expand a log, okay, basically that just means if you have two things that are multiplying together, that are inside, like that are a part of the of statement, so like log base 6 of 7 times 11, basically what you can do to come up with the value or the same value is going to be to expand it with the product rule. All that means is whenever we multiply, if we have log base 6 and then we have of 7 times 11, we're going to have log base 6 of 7 plus log base 6 of 11. It works the same. However many terms that you have multiplying together, that's how many things you would have, in this case, adding together. So if I have log of, so there's no base, so it's log base 10 or just log of 100 xy, then we're going to go log of 100 plus log of x plus log of y. Now on this one, to be perfectly honest with you, I don't know what the online assignment is going to want you to do, to be honest with you. What is, if there's no base, it's really log base 10, right? Okay, so realistically, and I'm just really looking at the first part, I'm not really looking at the log of x and the log of y, I'm looking right here. Okay, so if I would rewrite this as log base 10, is there another way to write 100 with a base of 10? 10 squared. So from what we talked about in section 2, if we have bases that are the same, so if the base of my log and the base of my exponent are the same, what is the log base 10 of 100 or the log base 10 of 10 squared, what is it equal to? 2. Okay. Again, I'm not sure if I completely simplified this out, to be honest with you. So what's here is going to be just 2. So if I would rewrite this, I would just say that it's 2 plus log of x plus log of y. The quotient rule works the same way. The only thing different is if you're multiplying and we expand it and we add, whenever we divide, we're going to subtract. Okay? Whatever's on top goes first. Whatever's on bottom will go second. Okay? So if I have log base 8 of 28 divided by x, I'm just going to have log base 8 of 28 minus log base 8 of x. I can't turn the 8 into a base of 8. Okay, so there's nothing that I can do there to where anything can simplify anymore. Whereas on 4, if I have the natural log of e to the 5th divided by 11, so I have the natural log of e to the 5th minus the natural log of 11. Now from what we did yesterday, remember that you can write the natural log as log base e. So if you have log base e of e to the 5th, what's going to happen here. What's that going to turn into? 5, right? So I'm going to have just 5 minus the natural log of 11. Then the last one in terms of expanding is what's called the power rule. Okay, basically, if you have anything to a power, all you're going to do, okay, all they did here was just take the power that they have out here and just move it to the front. Okay, nothing else changes unless it can simplify. Nothing else is going to change. Okay, so if I have log base 6 of 3 to the 9th, don't do 3 to the 9th. Don't take 3 to the 9th, just take the 9, slide it out in front, so I have 9 times log base 6 of 3. I can't do anything with the 3 to have a base of 6. Nothing like that. Okay. Same way, even if you start with a square root, or in this case a cube root. Okay. Remember that this is the same thing as the natural log. Anything to a root is really x to the 1/3 power. So what am I going to do with the 1/3 power? What am I going to do with this? Where's it going to go? Slide it out in front. So I have 1/3 times the natural log of x. Then the last one. Now this one has two things going on. Okay, so the first thing I have to do, I have log of x plus 4 squared. So that 2 is going to have to go all the way out in front. So then I have 2 times log of x plus 4. Okay, no it doesn't, I'm thinking multiply. So didn't need to do anything there. Okay. Now, I will kind of add like an 8. What if it, because this is what I was thinking whenever I saw it, what if I have log of 4x squared? The 2 is going to go out in the front, right? Okay, so this is like an extra. So I have 2 times log of 4x. What would I need to do with the 4 and the x?
To divide it and do the adding.
Right, okay. So the 4 and the x is getting multiplied, so it would have to be an addition. The biggest thing here is, and it's really up to you as far as how you would do it, is you would either need to go 2 times log of 4 plus log of x, okay, or you would have to go 2 times and basically distribute it, log of 4 plus 2 times log of x. Okay, I'm not sure if you'll have anything like that, but that's just one that I think you just need an extra example there, just because that's a possibility. That's immediately what I thought of whenever I saw the x plus 4 instead of, I was reading it as 4x instead of x plus 4. So if you have multiple parts, especially if you have the exponent and you have to bring it out in front, that 2 has to go to every single part in there. Whenever we condense, we do the same thing, we just go in the opposite order. So when we expand, we want to have basically as many logs as possible, whereas whenever we condense, we want to get it down to where there is a single log that all have the same base. Okay? If there are multiple bases, then we can't put them together. They have to have the same base. But if they have all the same base, then everything needs to go together. So to write it as that one single logarithm. So if I have log of 25 plus log of 4, I'm going to rewrite this to where I'm just going to have, it's a plus, so what am I going to do with the 25 and the 4? I'm going to have log of 25 times 4, which is really what? Log of 100. Now, again, not sure what they are going to want as far as like an answer. For me, what I would say, since you have no base, I really have log of 10 of 100. What did we already talk about that is log base 10 of 100? 10 squared, right? So I have log base 10 of 10 squared, which is really going to be what? Just 2. Okay? I'm not sure, to be honest with you, if they're not going to want you to stop right here or here. Okay? It's going to be one or the other. It's not going to be any of the ones in between. Okay? If they want you to write it as a single log, then you would just stop basically at that second step. If they want you to completely simplify this thing, then in my opinion 2 is as far as it would go. Okay? I would take it all the way basically to where it's as small and condensed as possible. Whereas whenever you have always look at the number in front if you have one. So like that 4 is going to go to the power here. The 2 is going to go to the power here. Okay? If you can think of these as exponents, like where does the negative exponent normally go? Usually goes on the bottom, right? So if I have log, whoop, so the 4's going here, 2's going there. So if I have log base 3 of x to the 4th plus log base 3 of 5 minus log base 3 of y squared. Negative exponents go on the bottom side of the fraction usually, right? If everything's up top and it's a negative exponent, it's going to go to the bottom. Think of it the same way with division. Okay, especially if you have more than one thing. Okay, if you have, like I have 3 terms. So either all 3 are going to go on the top, maybe at least one of them is going to have to go on the bottom unless they're all negative. Okay, but the 2 here are both positive, so I'm going to have log base 3. So what am I going to do with the x to the 4th and the 5 is just going to be 5x to the 4th, and then I'm going to have y squared on the bottom side. Okay, if you can think about these as exponents, and if it's negative, think bottom side of the fraction. Okay, if it's positive, it's going to stay up top. That way, no matter the order, because it doesn't really, depending on where everything's at, okay, unless it's separated by a parenthesis, then okay, things will go where they need to go as far as if it's a positive or if it's a negative. Last one on 14, then it's subtraction. So I'm going to have log. Now, again, since everything's inside the parenthesis, I'm going to have 7x minus 6, and then the x is just going to go on the bottom. The biggest thing with any of these is to make sure, always look out in front first to see if there's a number out in front that I need to turn in and put it as an exponent. The next step then is to see, do I need to multiply these things together or do I need to divide them together? Then the last part is just what's called change of base. If you have a regular TI-83 graphing calculator, you're going to have to put this in as y in the y equals to graph any of these as change of base. Okay, if you have a 83 plus or higher, like an 84, something like that, you can put it to where it actually has a base, and I can show you how to do that later, or where it's at. So whenever we do change of base, you're basically going to turn this into a common log or a natural log. So we're basically putting this everything in base 10. So whatever it's basically your of number over your base is what you're going to do. So if I have log base 5 of 140, then all I'm going to do is I'm going to take log of 140 and I'm going to divide it by log of 5. Okay. It makes it to where you can easily evaluate, okay, with anything, with a scientific calculator, with regular graphing calculators, but all you have to do, okay, if I get out of this and so whenever you type it in, the biggest thing I would tell you is whenever you type it in to a calculator, if you do change of base, is to make sure that you have a parenthesis around everything. So like if I go parenthesis and I'm just going to hit log of 140 divided by log of, what was it, 5? And then hit enter. So it's 3.070. You'll probably just round to like 2 decimal places, maybe 3. Okay. If you have like an 83 plus or an 84 plus or 84 of any sort, what you can do to kind of, in this case, to shortcut it, is you can go to math, and in the math section, I would just up arrow where it says log base for the A. Okay, it's the letter A. So you hit enter, and it'll automatically put it as, so my base was 5, my of number is 140, and it's the same value. Okay. In the olden days, whenever all you had was an 83, like you can do the same thing with a log here, but what you had to do, like if I wanted to graph something with x or 5x or whatever, and what I would have to do before is I would have to take log of x plus 1, and then I would have to divide it by log of 4. Okay, so that's how I would have to that's how I would have to do it before. Like whenever we had a graphing calculator before, they had this. So just know, depending on what you have, 83, you're going to have to do the one on the top. 83 plus or 84, you can do the second one. Same way with the natural logs. You can turn any of these. Basically, if you have the natural log, you can do this. It's going to be the same value. So like if I have log base 5 of 140, okay, if I do the natural log of m and over the natural log of b, just like I did before. So if I go right back out to my regular window and I hit the natural log of 140, make sure you close that parenthesis and divide it by the natural log of 5, I'm still going to get the same value. Okay, so you can do change of base either with a natural log or a log. It does not matter. Okay, if you have to evaluate and you have to do change of base, you can use either one. Okay, either as a natural log or as just a common log or log base 10.